Authorization is the function of specifying access rights and privileges to resources. More formally, to authorize is to define an access policy. For example, human resources staff is normally authorized to access employee records, and this policy is usually formalized as access control rules. During operation, the system uses the access control rules to decide whether authentication shall be granted or rejected. In the application, what resources the users will be able to use is determined by the authorization process. There might be different roles and users in the application, and every role has its own access privileges. We should identify each user or role, find out the permissions given to them, and try to push each user for unauthorized transactions. We try to find the weaknesses and vulnerabilities of the application's authorization mechanism and escalate our privileges. When the application does not control parameters coming from the user, you can process some unauthorized operations. The scenario displayed on the slide is a true story. The user has only view permission on the product. When she wants to view a product, the URL is prepared as seen on the slide by the application. Now there's a parameter named action, and its value is view. What if we change the value of the parameter as delete? Privilege escalation is the act of exploiting a bug, design flaw, or configuration oversight in the application in order to gain elevated access to resources that are normally protected from an application or user. The result is that a user with more privileges than intended by the application can perform unauthorized actions. If a normal user accesses functions or content reserved for other normal users, it's called horizontal privilege escalation. For example, Internet banking user A accesses the Internet bank account of user B. If a lower privilege user accesses functions or content reserved for higher privilege users, that's called vertical privilege escalation. For example, Internet banking user accesses site administrative functions. There are two real-world privilege escalation examples in this slide. In the first example, the message sent to a user has an ID number. Is it a random number, or is it a number increasing regularly? Here, the next message has the next number's ID. For instance, if the message ID is 12, the next message ID will be 13. Changing BID, we are able to read a message which is for anyone else. No matter what the ID number is, the application should perform an access control in each attempt. Now, in the second example, there is a hidden field with a name of list_admin and the value of F. Assuming that the F is for false, changing it to T for true, we get the admin role in that application. Path traversal attack is also known as .. directory traversal, directory climbing, and backtracking. This attack aims to access files and directories that are stored outside of the web root folder. By manipulating variables that reference files with .. sequences and its variations, or by using absolute file path, it may be possible to access arbitrary files and directories stored on the file system, including application source code or configuration and critical system file. It should be noted that access to these files is limited by system operational access control. So let's see the attack in a real-world example. While examining the application, we saw an attribute value pair with the attribute name of template. After just a few tries, we realized that there are different templates for the website, and the application decides which one to use. In the source code, it's seen that the value of the template attribute of the cookie is used as the file name directly. Change the template file name, put a few .. followed by etc. and password folders. Now here there are two things we should note. First, we assume that the server hosting the application is a Linux machine. Even though we don't know the operating system of the server, we can find it easily after a few attempts in this attack. The second, .. brings you one folder outer. We try to reach the root folder first, then go to the etc/password file, Redundant dot dot slashes are harmless, which means if you send dot dot slash after you reach the root, no error is given. So you can put dot dot slashes in as many times as you want. But you see, the response of the application contains password file content as well.